Hello everyone and welcome to our online courses on Mathematical Olympiad. I'm Sami Rahma, I'm a silver medalist and I'm on 2013 and I spent my last 6 years teaching for the Mathematical Olympiad. And I'm really glad to be here today and giving lectures in this course online. We're going to review video after video some kind of problems that are gradually increasing in difficulties. We're going to start with some easy problems and then we hope we can go to some higher levels. Now, if you're an Olympiad guy or you're just about to start your Olympiad career, we hope this is your way to go. Keep up with these videos along with the instruction we give in the bio, and I promise you a nice watch and interesting problems. Also, throughout the solution, we're not just gonna lay down the solution on the board. We're going to explain how the mental process worked and how possibly could we get to each step of the solution and how we worked it out. What are we waiting for? Let's get started. Now let's start with our first problem. It's going to be geometry, an easy one as promised. We have a triangle ABC with D the midpoint of BC. Also, E is the midpoint of AB. F is the midpoint of EB. Now, given that the area of the triangle ABC equal to 96, they're asking for the area of AFD. Now, probably this is your first time dealing with areas, but I can tell you this for sure. You will need this little theory over here. Theory says that if you join the vertex A as shown in the figure with the midpoint of the side BC with the midpoint of the side BC, you will cut the area in half, meaning that the area here equal to the area here just because you join the midpoint of BC. Now to prove this, of course, we always need to prove little theories when we learn them because it will get more acceptable for your brain to use it next time. And the proof easily is draw a perpendicular, yes, a right angle over here, and let's call it H. Easy as that. The area of A and B equal to MB multiplied by AH over 2, right? Half AH multiplied MB. While the area of AMC equal to MC multiplied by AH over 2. But as we know that MB equals to MC. So easy as that, we establish that the area on the right equal to the area on the left. So the theory is established. Once you join A with the midpoint, you cut the area in half, alright? Now, this kind of theory is easy, it's acceptable for the brain, it makes a lot of sense, I guess. Yeah, so once we learn it, we should never forget it. We should use it in really common sense. So, let's really use it. Starting with 1916 of ABC. The whole ABC is 96. So ABC is, yes, it's the half of it, which means 48. And ADB should also be 48, right? And before I write it, I can notice that E is also the midpoint of AB. What does that mean? Yes, it means that also the E cut the area in half. So we have here 24 and DEB is 24. Now what I do really want is ADF. So what's our next step? Indeed, we should notice that F also is the midpoint. So 24 is cut in half. Right? Now ADF assembles that is equal to 36. And now since we started with the geometry problem, we decided that we should complete with a series of geometry problems. And a similar one actually. We have here a rectangular shape divided into 7 congruent little rectangles as shown in the figure. These 7 are congruent, okay? This and this and this are the same, and these are the same, even though it's slided a little bit. Okay, so we have 7 congruent small rectangle and the large one. They're saying that the large rectangle has an area of 525 meters squared, okay? And they're asking for the side of each small rectangle of these 7, okay? So I think it's delightful. It's a wonderful problem as it looks. Yep. So what should we do at first? What's the first clue that comes to mind? Yep, this 525 must be divided by 7, which means that every small rectangle has an area of 75 exactly. So if we said that the sides of the rectangle is x and y, the first information we got is x multiplied by y equal to 75. This is the first information. We have 2 variables, 1 information, not enough. We should get some other information about x and y. Now, you tell me, what can we get from the figure over here about x and y? Of course, I want you maybe to pause the video a little bit, think about it, and resume it just when you get some idea and compare it to mine, okay? That's the benefit. You can pause it whenever you want and just resume it as soon as you get some idea, okay? Alright, the idea we got was x, 4 x's because of the 4 vertical rectangles, and when we shift the rectangle into horizontal position, we got x here, okay, but the most important is y over here, and y, and y. So it wasn't just a coincidence that when we put 3 rectangular horizontal, they fit with the 4 vertical one. It wasn't coincidence. It should mean something. What does that mean? It means that 4 x's is equal to 3 y's exactly. Otherwise, they won't fit into one large rectangle. Okay, so let's say 4x equal to 3y. Now we have the 2 information that we needed in the first place. How do we find x and y? This is symbol algebra. Symbol algebra, people. What are we gonna do? Yep, you can pause it. And think of it. But if you pause it enough, you should substitute one of the variable in the first equation. Yes, that's it. You can say that y equal to 4x over 3. You see, we isolate y alone. Nobody with y, she's alone. We isolate it and then immediately we substitute. We substitute in the first equation. We got x multiplied by 4x over 3 equal to 75. Okay, equal to 75. Now, also symbol algebra gives us 75 multiplied by 3 over 4 is equal to x squared. Now, what is x alone? Take the square root. This is 25 multiplied by 3. Give the 3 to its other 3. And we got 5 multiplied by 3 on 2. You see how we square rooted? Yeah. And this is equal to 7.5. Now, don't forget the y. They're asking for x and y. Don't forget. Don't finish over here. You still have to get the y. How do we get the y? We get it from the time we substituted it. Alright? It's always like that. You get the y from the moment you substituted it. Now let's say y equal to 4x over 3, which means 4 multiplied by 7.5 on 3 equal to 10. Okay, let's go with the third problem. Now enough with areas, now something new. Something new like this one. We have two equilateral congruent triangles. We have two congruent equilateral triangles. This is a huge people. We have a lot of equality here. Like what? Like AB equal to BC equal to AC. The side of equilateral. Now they are congruent as well. So which means that this side equal to this and this and this at the same time. 6 sides are equal. Okay? Now they're saying that if ACD equal to 70, find AED, the angle defined by x. Now, what can we do to evaluate the x angle? Think about it. Yes, there is a reason why these two equilateral triangles meet in C. The one who wrote this problem has a reason for this two equilateral triangle to meet in C. What is that reason? I mean, why should these equal sides be close to each other? Think about it. That's right. That's right. The triangle ACE is an isosceles. That's right. The triangle ACE is an isosceles. Right? Right? AC is equal to EC. So it's not a coincidence that they meet in C, is it? No, it's not. So we have this 70 and this equal to, of course, you know it from the first time, it's 60. Now this in total is 130. And since we have an isosceles, it's easy to deduce that this is equal to 25. Also this equal to 25. Now we got this one, but we need x. What shall we do? Yes, the whole angle is 60, so x equal to 35, and it's over. Alright, now some of you said something very, very amazing, that they noticed that C is attached to 4 sides that are equal in length, which makes what does it make it? What does it make C? Yes, it makes it the center of a circle of BADE, because it has the same distance from each of the vertices. Alright? Okay, that's good, but how could this help me find x? What do you think? Yes, C is the center, defines a central angle, and E on the peripheral of the circle, it defines a peripheral angle, and the peripheral angle, if attached to the same arch as the central one, it means that x is half of ACD, which means it is 35. This is huge. This is very good if you notice this. If you did not, that's not a huge problem, okay? You have an alternative way that is very good as well, and also have the idea of noticing this isosceles triangle, which is not that obvious, let's say, okay?